already know that the power assembly is the heart of your EMD. You know that a lot of engine maintenance also deals with the power pack. This is just one of a 4-part series on the power assembly. In this series, you'll see how to tear down and reassemble the power pack. Then we'll get into repairs on the head, repairs on the liner, and last, repairs to the piston, carrier, and rod. This program will tell how to disassemble, inspect, and reassemble the unit. It'll also take a look at how to determine the condition of the parts and whether they can be reused or returned for exchange. 2 other programs will show how to remove and reinstall a power assembly into the engine. In the last 3 programs, you'll see how to repair the liner, then the head, and last, the piston and rod assembly. When you finish watching these 4 shows, you'll have a real good handle on how to get a first-rate rebuilt power assembly from your own shop. All right, let's get started on disassembling and reassembling. First, we'll look at the right way to move it around, and then how to make a preliminary inspection to determine if it's worth repairing. If it's not, we'll see how it should be packed for shipment. If it can be repaired, we'll look at tearing it down, inspecting the individual parts, putting it back together, and we'll look at selectively fitting pistons to liners. If you need to store it, we'll talk about that too. Last, we'll even qualify the rod bearings for reuse or rejection. Before we start, here's a list of tools you'll be needing. It's lifted with a power assembly lifting tool. You can use a shipping case or some wood blocks to stand it up. You need a 3/4 inch drive socket wrench and extension, or an air wrench. Cylinder head lift tool, piston pulling eye bolt, a snap ring tool, a compression ring expander, a carrier holding fixture or a vise with copper jaws. You'll also need a bore gauge, thread lubricant, silicone grease, and some protectant like Tectile or Cosmoline. You may have already pulled your power assembly, so you might know that it has to be handled a certain way. The lift tool has 2 holes. Using one, it lifts straight up, and the other holds it at the right angle for entry to or removal from the engine. Care should be taken not to damage that rod while you're moving it or when you set it down to work on it. Okay, time for inspection and disassembly. All your power assemblies should be taken apart so that you can find out how much damage there is, even if the whole pack is going to be returned. That's so you'll know what damages are there and you won't get stuck with overcharges when it's sent in for unit exchange. To tear down the assembly, you can start by standing it in its case. Then remove all the holding tools and hoist. The next step is to remove the 8 head-to-liner nuts and washers with an impact wrench or a 3/4 inch drive ratchet. Of course, you'll reuse them later if they're in good shape. Apply the head lifting fixture and screw the 2 long bolts, 6 or 7 full turns, to secure the fixture to the head. Tightening the 2 lock nuts evenly will separate the head from the liner. Apply the hoist and remove it from the liner. Put it on a clean surface and take off the lift tool. Now you can use a knife or something to remove the gasket from the liner. You have to keep it level as you bring it up and off. If you don't take it off, then the piston rings will get caught on it as the piston and rod come out. Put the lifting eye into the piston with about 4 or 5 turns. Hoist it up to remove it and the rod. Lay them carefully on a clean surface. You don't want to scratch anything. Take off the hoist and lifting eye. If you don't have a shipping case that's empty and you have to lay your power assembly down to disassemble it, then there are a few tricks you should know. Get a wood block like the piston holding block and prop up the end of the liner. Before the head comes off, pull the piston and rod down until the bottom of the piston is even with the bottom of the liner. This makes it easy to get the snap ring off. Then you can remove the rod, carrier assembly, and thrust washer. Reach inside the piston and pull it out. The elevated liner helps you to keep from scratching the piston skirt. Be careful during that last inch of pulling the piston. You don't want it to fall out. Support it with one hand so that you can catch it when it comes out. Now, pull out the support block. Okay, break loose the head-to-liner stud nuts. Just barely, though, because now we'll put that block under the top end of the liner. All right, now, take off the nuts and washers. The rest of the disassembly is just like we described earlier. Now we've got 3 units separated. Let's begin an inspection. We'll start with the piston and carrier assembly. If you're tearing down your pack using a shipping case, you still need to get the piston and carrier apart. Get your snap ring tool and insert the ends into the 2 holes on the snap ring. Compress the ring with the tool and take it out. Now pull on the rod and carrier. It should come right out. You may need to jiggle it a little. Check the thrust washer. It may still be stuck inside the piston. Now stick the carrier and rod assembly into the carrier holding fixture. After you remove the bolts, the rod will lift off. If you don't have a holding fixture, use a vise with copper-protected jaws to hold the rod while you remove the bolts. When the rod is off, the piston pin will slip right out. Take a look at the insert bearing. There should not be any deep scratches, but there may be some particles stuck in the grooves. Whittle a wood stick and clean them out. If it's good, then leave the bearing in. If it's bad, replace it and the wrist pin. If the pin is damaged, then put a new bearing in with your new pin. You have to keep the bearing and pin mated, just like the basket halves should be mated with the fork rod. Let's go over to the piston. Put it top side up and get your ring expander. Take the rings off, top one first. When the 4 rings are removed, you can carefully turn the piston over and remove the 2 oil scraper rings. If you come across a ring that's stuck, get a screwdriver and insert it behind the ring at the gap end and pry outward. If that doesn't work, carefully use 2 screwdrivers to try and move or loosen the ring. At this point, if you think your piston needs any repairs, you should stop and watch the program on Repairs to the Piston and Rod Assembly. The first step is to remove the valves from the head. The head should still be on a clean work surface of wood or cardboard to prevent scratching the firing face. It doesn't matter whether you use a single or multiple spring compressor. We're using a multiple compressor here. It simply screws into 2 threaded holes designed for the tool. Once it's screwed in, bring the handles down to a horizontal position. This will allow you to get to the valve locks so that the springs can be removed. Once the locks are removed, release the spring compressor and remove the tool. The springs and the retainers will come right off, and the valves will slide out. That's the work on the head, so if you need to repair it, check the videotape program that shows all the steps in repairing the head, because the exhaust valve seats must be reground before putting in new or reconditioned valves, just as the liner must be honed before reuse. Let's check the liner. Look in the water inlet hole. The deflector should be in good shape. If not, another one will have to be installed. You should get the liner bore gauge and check its dimensions at 90-degree angles, at 2 inches, 6 inches, and 12 inches deep into the liner. This is to tell you if the liner can be used again after being honed. So let's look at the liner and piston together, because you need to make sure that their specs are good, or if selective fitting might be needed. You can mix pistons and liners in order to get within the tolerance allowed for piston-to-liner clearance. This is explained again in the liner repair section of this series. This selective fitting of pistons and liners is done only when the liner bore size exceeds 9 68/1000 inches at 6 inches from the top of the liner after the liner has been honed. You can use a liner that measures 9 68/1000 inches to 9 73/1000 inches at that 6-inch location, but only if you find a piston that will leave no more than 22 thousandths piston to liner clearance. Say you had a 9 73/1000 inch liner. You'd have to have a piston with 9 51/1000 inches skirt diameter. Review the liner repair program for honing and cleaning procedures. The type of rings are critical too. Cast iron liners have certain kinds of rings. Chrome liners have different rings for the piston. You'll know what kind of rings to use by looking in the parts catalog under your engine model number and then choosing the rings for a cast iron or chrome liner, whichever you need. While we're talking about rings, there's one more thing you need to get: the ring groove gauge to measure the top ring groove wear step. Keep trying until you find the one that just fits all the way into the groove. Then measure again to find the one that goes in about 3/4 of the way. The difference is the amount of wear and is called the wear step. Standard width rings are used in the lower 3 grooves. If the wear step is more than 3/1000 of an inch, it'll have to be removed. If the whole groove is more than 201/1000 of an inch, the top groove must be recut to 1/64 or 1/32 over size. This will probably have to be done in a shop. All right, let's look at where we are. We've decided whether or not our parts are good enough to reuse. And we've honed the liner and cleaned the parts real well. We should be able to begin reassembly. As we go, we'll oil every part to help protect it and act as a pre-lubrication. We'll start with the carrier and work our way up. If a new piston pin is going to be used, put in a new bearing. If you use an old one, the same pin and bearing must be used, and the bearing should be in the same relative position to the pin as it was when it came out of the engine. Don't use a bad bearing. The bearing slot should be wiped clean with an oily rag. And the bearings slid into place. Center it and check the tangs so that when we bend them, everything will be centered. Okay, strike the center of the tang with an indenter tool or screwdriver. Make sure it's snug as you go to the other side and do the same. It should not move at all. Now, coat the whole thing with fresh, clean engine oil. Get your pin, oil it, and slide it in so that the small index hole on the end of the pin is on the same side of the carrier as the piston cooling inlet hole. Make sure it rotates. And then you can get the rod. Find the serial number on the rod and put it so that it too is facing the same side as the oil cooling hole on the carrier. Put some ThreadTex 2303 on the bolt threads and install the bolts. Go ahead and tighten them down. Get the bolts down to about 10 foot-pounds and check the spacers. If they move, you'll have to pull that bolt and find out what's wrong. If the spacers don't turn, torque the bolts to 450 foot-pounds. Now get the piston and install the rings. This is well explained in the program that deals with repairs to the piston, carrier, and rod. You'll put the bottom rings in place first, then the top rings. Always check for any rings marked top on the side and put the word top toward the crown. The number 4 piston ring is a tapered face ferrix-filled ring. Ring 2 and 3 are chrome-faced and can be in either the number 2 or number 3 groove. The top, or number 1 ring, is also chrome-faced and has chrome on the sides, but it is several thousandths thicker than the other compression rings. It'll have top groove only stamped on it. When all the rings are on, the gaps must be staggered. The program on piston repairs will also tell you how to do this if you have any questions. If you have a chrome liner, the top 3 rings are going to be different. So make sure you've got the right set of rings for the liner you're working on. When that's done, turn the piston over very gently and make sure the inside is clean. Apply some new oil on the thrust washer platform and then put the thrust washer in place. Get the rod and carrier and put it into the piston. When it's seated, it should rotate freely. Get your snap ring and snap ring tool and install it into the piston like this. Now, with a feeler gauge, check the clearance between the ring and the carrier. It should not exceed 25 thousandths of an inch. So much for the piston and carrier. Let's check the liner. Is it good and clean? Is the water inlet deflector in place? If so, put the liner in the power assembly shipping case. That way you can stick the rod and carrier in from the top and get it down far enough to allow the head to be put on. If you don't have a shipping case, you could stand the liner up on blocks so that the rod goes down between the blocks just enough to have the piston crown go below the head-to-liner gasket surface. All right, get your ring compressor sleeve and clean it out. Put it on the liner and oil it down. Oil the upper part of the liner bore, too, so that the piston rings will slide in okay. Now, with the lifting eye in place, raise the piston and rod assembly with a hoist. Oil the whole piston surface. Check the ring gaps for proper positioning. The rod's serial number needs to be on the same side of the liner as the water inlet opening. Carefully lower it into the liner. You might have to jiggle it a little bit so it'll slide on down. When you get the piston crown, even with the gasket surface, you should go on far enough down so that the rod is hitting bottom to allow you to remove the hoist. Be sure and take off the lifting eye, too. Clean off the gasket surface. You don't want any dirt or oil anywhere along there. The gasket will have EMD Top 645 written on it. This should face upward. Be sure that the notched hole is over the pilot stud. The pilot stud has this little flange on it. Now install the head-to-liner water seals and the heat insulators into the counterbores, and be sure they're not cocked in the hole. Now you're ready for the head. You might need to put in some valves. If you do put some in, use only new or reconditioned valves. Repairs to the head, like the installation of valves, are covered in the videotape that you may have already seen. It's an easy process. Drop one in each of the exhaust ports. We'll need to check the vertical distance from the fire face. Check with a feeler gauge to see what the distance is between the flat of the valve and the straight edge. It shouldn't be any greater than 93 thousandths of an inch. If it is, and it's a reconditioned valve, replace it with a new valve to try to get the required dimension. If it's still greater than 93 thousandths of an inch, the valve seat has been ground too deeply into the head, and the head will have to be rejected. If all four valves pass this test, carefully turn the head right side up. Be careful not to slide it around. You might scratch the fire face. Now install the valve springs and valve spring retainers. And put the spring compressor in place. Now compress the springs and install the valve keepers. Make sure that they're in good condition before you put them in. Then you can pull the valve spring compressor off. All right, with the valves now in place, you'll need to check the stem height. This tool can do it, and it's called a valve checking tram. Again, Section 2 of the manual and the program on head repairs will explain this if you have any questions. The clearance must not be more than a 1/16 of an inch. If it is, replace the high or longer valve. Don't grind the valve tip, because these are hardened surfaces, and grinding could make them crack. Remember, 1/16 of an inch is the maximum clearance. With that done, flip the head over and rest it gently on the rocker arm studs with the firing face toward you. You should have a valve seat seal tester. If it's old, you can test it on a piece of glass. It should stick for at least 2 minutes. To test the valves, clean off the face real well and put a light film of oil on the tester cup. Stick it on over one of the valve seats. It should stay for at least 2 minutes without losing suction. Just pull the release trigger to get it off. If the suction tester falls off in less than 2 minutes, the seat will have to be reground so you can get a better seal. You should be ready to put the head on the liner now. Make sure the fire face is clean. Now, lower it over the liner. The test valve hole should be directly over the water inlet hole. That way, you'll also have the pilot stud in the correct stud hole. Recheck the water seals to be sure they're not cocked. If it stops before it's all the way down, it's because of the head lifting tool. Simply loosen the nuts until it goes down. When that's done, remove the lifting fixture and put on the hardened washers and lubricate the stud threads with Texaco Thread Tex 2303. Now the nuts. Snug them down. After they're snug, follow the proper torque sequence and torque them all to 75 foot-pounds. Then, torque them all to 240 foot-pounds. You'll probably need someone to help hold the power assembly while you torque. Okay, the nuts are torqued, so let's put on the water discharge elbow. Both the head and elbow surface should be good and clean. A red O-ring will be used between the elbow and the head. 2 brown O-rings go on the other end and should be well lubricated with Dow No. 4 silicone grease. Put the elbow onto the head with the 2 Allen head bolts. Torque them to 30 foot-pounds. If you're going to store it, if you're going to install it, don't lift it until you get the piston held in place. If you're going to store it, use the holding bolt and block. If you're going to install it into the engine, use the piston lifting tool. Either way, you should not lift it until your block or lift tool is secure and locked in place. Lift it on up and install the lower liner seals if you're going to install it into the engine. With that done, put on the rod position clamp and you're ready to put her in the engine except for one thing. Check your connecting rod bearings. If they're used bearings, they can only be used on the same crank pin journal. Used bearings may have some minor dirt scratches, and that's okay. If the scratches look severe, or if there are signs of discoloration, use a new bearing. This area on the upper bearing shell where the blade rod rests is a pure lead flash overlay. Some of this area may show wear. That's okay. But like we said, if the wear looks bad, get a new one. Okay, you've got a power assembly all ready to go. You can store it or put it in your EMD and expect many hours of trouble-free service. So what do you do if you've got a part that's no good? Ship it. Same goes for anything that you're just not sure about because of not having the proper equipment to measure or check it with. Just about everything that you reject should be returned for credit. Liners that are scuffed or worn beyond dimensional limits. Pistons that need to be regrooved. Heads that are scratched or nicked in the sealing areas. Or rods that are questionable. Give the parts that you return or store a good coating of protectant like oil, Tectol, Cosmoline, or something like that. Put it on thick. That salt air gets to metal real fast, and unfortunately, we have to pay for all the damage.
This rod is an example of unnecessary cost to the user of an engine. We feel that the parts that come back in on unit exchange should be as well taken care of as the parts going out. This rod has a smooth surface in most of the areas, but somewhere between the time it was taken out of the engine and the time it got into the shop, it was either rained on or salt watered on it, and the blade of this blade rod is rusty.
If you have the original container to ship your parts in, that would be the best. If not, make up containers that are the appropriate size. If several parts are going in the same case, partition the case so that each part has its own compartment, because you know how careless some of these shippers can be. If you're going to store any parts, make sure they're clean, well coated with oil, and tagged with all the data, like bore diameter and skirt dimension. Pack them up, too. It'll save on cleanup when it comes time to use them. More importantly, it'll protect them from damage. One of the few times you'd be packing up the entire assembly is if you had a bent rod. Even a slightly bent rod could have caused enough stress to give you problems like this later. Packing it up is easy. You've probably unpacked a couple from their containers already. Well, just reverse the process. First thing, take off the water discharge elbow. You'll need to use an Allen wrench on it. The rod positioning clamp also needs to come off, and while you've got it on the hoist after having removed it, oil the inside of the liner bore. Get the rod, too. Tectile would be even better if you have some. Now, lower it into the shipping container. Get it all the way down in there and check to be sure it's settled in. Take off the lifting fixture and piston holding tool. Put some oil or Tectile into the injector well to protect it. Now you can put the piston holding bolt and the block in place. Put on the wood block over the rocker arm studs and apply the bolts that attach to the back of the case. Then the rocker arm bolts need to be put on. If it happens to be a fork rod assembly, oil the basket halves and fasten them to the container. Then all that's left is to put on the cover and fasten it. That's the whole process for tearing down and reassembling your power pack. The other programs on repairs will help you more on the actual repair work. Thanks for watching, and we hope each program will help you more than the last.
You know, the piston and rod assembly are under a lot of pressure all of the time, and the clearances are all extremely tight inside that cylinder. So anything that gets inside the piston area, like water or carbon or grit, that can crack, scratch, or score the piston, can end up causing an awful lot of trouble and costing an awful lot of money to repair.
Well, you know, piston and rod damage don't usually just restrict themselves to the piston and rod. Usually a lot of damage will be inflicted on other parts, like the liner and the block. So it's real important in reworking a piston and inspecting a rod to make sure that the parts you're putting back into that engine are in top-notch condition. That's what we're going to do in this program. We're going to disassemble, inspect, and repair a piston and rod assembly. The assembly really consists of 6 parts. The rod, which could be a fork or blade rod. The wrist pin, which is attached to the rod by 2 bolts. The wrist pin bearing. The piston carrier. The thrust washer. And the piston, which is held to the carrier with a snap ring. On the piston, there's also a set of 4 compression rings and a set of 2 oil scraper rings. Now, getting all this apart is really pretty easy. If you just remove the snap ring with this special snap ring tool, the carrier should slide right out of the piston. Then, by taking the 2 wrist pin bolts out, the rod can be lifted off and the wrist pin can be slipped out. Keep these parts together and don't remove the insert bearing. We'll figure out what to do with it a little later after we've inspected it. And finally, pull the rings off the piston. Use one of these ring spreader tools. If you try to get them off without one, you're liable to scratch the ring belt area, which could do enough damage to the piston to keep us from reusing it later. Now comes the cleanup. We'll start with the piston. You're going to need some fuel oil, a wire hand brush, a scraper, and one of the old rings that you ground down to a point, like this. Let me caution you about something. Use the scraper and wire brush only to remove the carbon from the crown. You can't use it on the side of the piston below the number 4 ring groove. And be careful in knocking the carbon off the piston crown. You don't want to put any scratches or gouges in the piston crown. Next, your ring grooves. You can use your modified ring that's been ground down to a point like this to get down inside of the groove. This is really an effective tool to use. Just scrape down in there until you've got all the carbon removed from all 4 grooves. Then give it a good rinsing with fuel oil and a steam bath with hot water. And then blow it with compressed air to get it dry. Let me warn you one more time. Don't use any abrasive, emery cloth, or wire brushes, or scrapers, or anything on the piston skirt below the number 4 ring. Now for the inspection. Some of the obvious things we'll be looking for are scuffing, scoring, cracks, and mechanical damage that might have been caused by a broken ring or a bent rod. Next, we need to check for the phosphate coating. Just because there's a little worn area on a piston where you see that the phosphate coating is worn off doesn't mean that the piston's no good anymore. You can have up to about 3 square inches of area where the coating is worn off before the piston has to be rejected.
Now, if this is the only problem that the piston has, it can be sent in to be recoated with phosphate.
Flip the piston up and take a look at the washer platform. You're looking for signs of overheating or galling that would keep a piston from turning freely on the thrust washer. Or you might see cracks in this area. Anything like this will cause a piston to be rejected. Look at the ring belt area. Now, this area is vulnerable to cracks. If there are cracks present in this area, they might be hard to see because they generally start at the base of the groove in the top corner and run along with the groove. So, just because you don't see any cracks, it doesn't mean there are not any there. You can give it a good inspection by either having it magnafluxed or using a dye penetrant. If you suspect a crack, go ahead and check it with the dye penetrant. It'll work the same on all parts of the piston. We'll show you how it works on the crown of this piston. It comes in a 3-part package. There's the dye, a cleaner, and a developer. The dye is sprayed on pretty thick. That has to set for about 30 seconds. Then you can wipe it off and clean it with the cleaning solution. Once that's dried, you can spray the developer on. Wait for a couple of minutes. If there are any cracks, you'll be able to see a red indication where the crack is. Now, this piston doesn't have any cracks, but this head does. This is what your crack will show up looking like. Now, one place you're going to want to look real closely for cracks is the upper corner base of the top groove. That's where most of the cracks will happen, in the ring groove area. Any cracks in any of these places are reason to reject the piston. Or if you see any evidence of physical damage, like this, the piston is automatically rejected. This one's kind of interesting. A piece of a ring broke off and got caught in between the piston and head. Here it's embedded in the piston crown. Now we need to check the piston size. You'll need this special ring groove tool. To check the ring grooves, let's start trying to fit these little gauges into the groove. Start with the smallest one first. Work your way around until you find one that fits snugly all the way down into the groove. Now write that measurement in your PMS logs. Then keep inserting the gauge blocks until you find one that will only go in about 1/2 to 3/4 of the way into the groove, and write that figure in your PMS log. The difference in the two measurements will give you an indication of what we call the wear step. This wear step is an area of the ring groove that the ring has worn away. If the difference in the two measurements exceeds 0.03 of an inch, the piston shouldn't be reused. Most of this wear you're going to find in the top compression ring groove. If it's more than this, you'll have to have the groove recut. But if it's going to exceed 201/1000 of an inch after it's been recut, you'll have to have it recut to the next oversize for use with an oversized width ring. 201/1000 of an inch is the largest width groove in which you can use a standard width ring. If it looks like you can have the groove recut and it will still fall within specifications, send it in to have it cut to the next oversize. If you're going to go to an oversized ring, check Section 3 of the engine manual. It'll give you all the specifications you need for recutting the groove. The next thing we'll do to the piston is check the piston skirt measurements at 4 locations. 2 at the bottom, below the bottom oil rings, at 90 degrees apart, and about 3 inches below the number 4 compression ring, at 90 degrees from each other. The minimum diameter is 9 46/1000 inches, and the maximum out of roundness is 0.05 of an inch. If the piston falls within these specifications, it's okay to go ahead and use it again. Now, the connecting rod shouldn't require anything other than just a general cleanup. Be sure not to use anything caustic or any alkaline cleaners on it. We're going to use Stoddard solvent, but you can use anything that's equivalent to Stoddard's that has a flash point of above 140 degrees Fahrenheit. Now, when you get down here to the blade rod slipper surface, you might find an oil stain. Don't bother trying to remove it because it won't affect the operation of the blade rod. If it doesn't come off with Stoddard's, don't use anything else, including steel wool. Now let's take a look at the thing to see if it's got any severe damage. First thing you ought to look for is any evidence of physical damage. If you see any places where something's been rubbing up against the rod, or if you see that the rod's been bent at all, this is a good indication that this rod is going to fail. Now, if it's bent, the I-beam section might have a little area that's been rubbed away where it's been rubbing up against the liner skirt. If you see this, be sure and go over and check the liner too. Now, down on the slipper surface of the blade rod, you want to check for overheating, scratches, nicks, rust, cuts, or galling. This should be perfectly smooth. Remember, it seats up against the bearing. Anything down here that indicates there's been a problem should be checked out, and if the problem looks like it might affect the performance of the rod should be scrapped. Now you might see a blue-black discoloration at the top side of the blade rod slipper foot. This is caused by the heat treating process during manufacture. This is normal. It's not caused by operational overheating. The surface itself shouldn't show any signs of heat discoloration. Next, check the serrations of the fork rod. You're going to be looking for fretting or cracks. The basket halves should fit right up into the serrations, and there shouldn't be any binding at all. Now, anywhere on the rod that you think you see a problem, take a good close look at it. If you can get it magnifluxed, this is a good way to be sure. If not, and you see an area that looks like it might have a problem, check it with the dye penetrant system. If you're not just absolutely convinced that the rod's in good condition, don't take a chance. Set it aside for either a more detailed inspection or send it in and have it inspected with the proper tools. Now there's one other check on the fork rod that you can do, and you need this plug gauge to do it with. This gauge has a go end and a high end. What you need to do is try to thread the go end into the bolt holes that are used to hold the baskets onto the fork rod. The go end should thread into the holes. Now as you screw it in, be sure and notice any binding that occurs or any indication of damaged threads. This go end will generally screw in pretty easily. If it wobbles a little bit, you're okay. If it wobbles a lot, you might have a problem. Turn the gauge around to the high side and see if it threads in. Now this isn't a no-go gauge. If it screws in freely, it indicates that you might possibly have a problem. If it's snug or tight, you know it's okay. If it shakes or wobbles, both the rod and basket should be scrapped.
At this point, check your bolts. If they are defective, replace them with new bolts.
The last inspection for the rods that we have is made on the fork rod only. Screw the basket halves together and attach them to the fork rod. Torque the upper bolts down to about 175 foot-pounds. This is 238 Newton-meters. The lower basket bolt should be at about 75 foot-pounds, or 102 Newton-meters. Now, take 3 readings at about 60 degrees apart. Now, the average of these dimensions shouldn't be more than 7 626 of an inch. If the bore is larger than this, you're going to have to return the basket halves and the rod for rework. Now be sure to keep the basket halves with the fork rod. These things are line bored as a complete unit and aren't interchangeable with any other fork rods. Now back up at the saddle end of the rod, you need to take a look in the area that the piston pin sets in. First thing you may be able to see is this figure 8 pattern. This is where the piston pin contacts the saddle, and it's a normal condition. If you see any nicks or protrusions or fretting, you need to take a fine cylindrical stone or 150 grade abrasive paper and remove them. Now take the thrust washer off and clean it with a soft cloth. Really, about the only inspection you can make is a visual inspection for galling or overheating or cracks. If you see any damage like this, you'll have to replace the thrust washer. Take a measurement with your micrometer.
With your micrometer, measure the thrust washer thickness at these points.
Minimum thickness is 175 thousandths of an inch, and take a reading at several points. You shouldn't see more than 3 thousandths of an inch variation in the thickness. If you do, then replace the thrust washer. Otherwise, if the thrust washer is nice and smooth and shiny, it's probably in good condition and you can reuse it. If you find anything wrong with the piston pin and you have to replace it, you're also going to have to replace the insert bearing. We'll go over that in a minute. First, let's go ahead and make a thorough inspection to determine if it's any good. The insert bearing is the most critical. Don't remove it until after you've determined whether it can be reused or not, and this is just a visual inspection. Let's clean it up first. Find yourself a wooden stick. You might cut a point on it so you can get down into the grooves of the insert bearings to clean them out. Don't use anything metal down here because this is a really sensitive surface. It's silver coated, and if you use anything harder than the silver, you're going to end up scratching some of that silver off of there. If you do that, you're going to have to replace that bearing, and it ain't cheap. Once you've got that done, you can go over the bearing with a petroleum solvent that's got a high flash point, something like Stoddard solvent. Now, don't ever use an alkaline or caustic solution to clean these parts with, or abrasive materials like steel wool or emery cloth. I don't care how stubborn the carbon is on these parts. Anything abrasive is going to damage the bearing beyond use. Okay, now let's take a real close look at that bearing. Now, we're going to be looking for damage like galling, smearing, or scoring of the bearing material, or for relatively large areas of pitting from corrosion, or flaking or shelling of the bearing material. Anything that looks like it might create friction between it and the wrist pin. If you see any signs of anything like this, the bearing will have to be replaced. Now we'll go over how to replace the bearing in just a minute. If the bearing looks like it can be reused, check it to make sure it's tight. It shouldn't jiggle back and forth at all. If it is loose, take a punch and a hammer and tap the tang down a little bit so that the bearing is nice and snug. Next, take a good close look at the piston pin. We're especially interested in the surface that touches the bearing. The bearing surface should be free of any roughness and have a mirror-like finish. Only where it touches the connecting rod can fretting or protrusions on the pin be removed with a fine stone. Check the pin diameter in the center and each side of center. There should be no more than a 2/1000th of an inch step. Check the two bolt hole threads with a tap. If the threads are damaged, replace the pin. If a new pin is needed, a new insert bearing will also have to be used. Now, let's take a good close look at the carrier and go over the procedure for replacing the bearing. If you have to replace it, just pry the tang up and the bearing should slide right out. It might be a little bit tight because of carbon buildup back between the bearing and the carrier, but it shouldn't be all that hard to get out. Clean this area out real good. Get all the carbon and trash out of there. Wipe it dry. Very carefully, and you've got to handle these bearings carefully, remove the bearing from its packaging and slide it into the carrier. Tap one of the tangs down. Then position the bearing so that it's snug against the bent tang. Then tap the other tang down. Make sure that they're locked tightly in place and can't slip out. It should be perfectly tight.
On the carrier, we're going to be interested in looking for damage along the thrust washer platform area, in and around the insert bearing. Look for evidence of heat discoloration or galling and tearing of metal on the thrust washer platform.
Anything that would keep the thrust washer from spinning freely over the platform surface is going to be a problem later on, so pay close attention to this area. And if you see any potential problems, be sure and put the piston carrier aside for closer examination. Well, that takes care of the inspection and repair work that we can do on location. Now let's reassemble our parts so the piston and rod assembly can be put back into service. First, lubricate the insert bearing and piston pin with clear engine oil. Then slide the piston pin into place. Make sure that the small hole in one end of the pin is facing the same side of the carrier as the piston cooling inlet oil hole. The rod should be bolted on next. On both the blade rod and the fork rod, the serial number should be facing the same side as the piston cooling inlet oil hole in the carrier. The bolts should be lubricated with thread techs and tightened to about 10 foot-pounds. Check the spacers, then torque the bolts to 450 foot-pounds. Now for the piston rings. Make sure you've got the proper sized rings for the piston you're using. Refer to your EMD manual or parts catalog. Set the piston with the crown facing down. The double hook scraper ring goes on first with the word top pointing toward the piston crown. It goes in the number 2 groove. The bottom ring, the spring-loaded oil control ring, goes in the last groove. Be sure you put the spring ends 180 degrees away from the ring gap. And install the ring with the word top pointing toward the crown. Make sure the spring gets seated in the ring. If it doesn't, the ring will break when the piston is installed in the liner.
Turn over the piston and put on the top ring.
The number 4 compression ring is next. It's marked top 2. The top should face the crown. The second and third compression rings are identical and can be put on either way. There isn't any top or bottom. As you put all of these rings on, be careful not to scratch the sides of the piston. Finally, the number 1 compression ring. It's marked top groove only. Either side can face up. Once that's done, adjust the ring gaps so they're staggered. The first and second rings must be 180 degrees apart. The third should be 90 degrees from them. The fourth should be 180 degrees from the third. The oil control rings should be 180 degrees apart from each other. You'll be checking this again just before you install the piston. Meanwhile, don't set it down on its side. You might pick up trash in the ring area that will cause problems later, or you might damage the bottom rings. Turn the piston upside down. The thrust platforms and thrust washer should be lubricated. Then put the thrust washer on. Now the carrier can be installed in the piston. It should bottom out so that you can get the snap ring into the snap ring groove. Now check the snap ring clearance. It shouldn't be more than 25 thousandths of an inch. Okay, this piston assembly is ready to be installed into the liner. We check the piston crown inside for cracks. We check the wear step in the first ring groove. We've replaced the rings. We checked the thrust washer platform surface. We checked the thrust washer. We checked the piston carrier and the piston pin and the insert bearing. We also checked the condition of the rod and of the slipper surface of the blade rod and the basket area of the fork rod. That's really about all you can do on the rod. This piston assembly meets all specifications that EMD requires, and you can be confident that it's in top-notch condition. Now it can be reinstalled into the power assembly, and that's covered in another program. Well, it's been called a liner, a cylinder, combustion chamber, and a hell of a lot worse things. But the one thing that it is where all the activity takes place in turning fuel into useful energy. The liner is where all the action takes place. In fact, 16 miles of piston passes across the liner's surface every 60 minutes. With all this metal-to-metal contact, and considering the close tolerance of the piston and cylinder, wear is just going to occur. In this program, we're going to take a look at the liner bore that has been removed from an engine and evaluate the damage. If it's repairable, we're going to show you how to ream the wear ridge and hone the liner. If it's not repairable at your location, we'll tell you how to determine whether it can be repaired in a shop or not. Now, one of the first things you ought to do is make sure the liner is completely clean. If it's not, go ahead and give it a good thorough cleaning with some sort of solvent, fuel oil, Varsol, or something like that. If you find carbon or oil that's really baked on, you can scrape it off if you have to, except in the liner bore area. Make sure that all traces of the old head-to-liner seals are completely removed and the counter bores are clean. After you've done that, you can finish cleaning it and give the entire liner a good visual inspection. The most critical area for visual inspection is the bore area itself. First, you should check the liner bore condition and be looking for things like scuffing, cracks, port milling, framing, and gouging. We found a liner that has a lot of these problems, and Mac McGee of Geosource's Power Systems Division is going to go over the problems of this particular liner.
There's several examples of the different damages it's done to liners. You'll notice in this liner, even though it's been honed lightly, there is still evidence of the varnish, this brownish or orange colored that is left to deposit on the liner itself. You see a line coming down and it comes right close to the corner or comes right out of the corner of the ports. Now this would be streaking caused by a carbon particle getting hung up on the rings, and it just goes up and down and makes a mark in the liner. It is not a score. You have an area right here that is a hot spot in that liner, and at some time or other, this liner became overheated.
This area shows minor overheating. No worse than this, the liner is okay. Severe overheating will usually cover a larger area and can result in distortion of the liner bore or a thermal crack. It'll appear as heat discoloration on your liner. If you see any, chances are it's due to water restriction in the port bridges, which is usually caused by a restriction resulting from the casting process. Such a liner should be rejected.
In this area of the ports, you may see this in some of your liners, although not this severe.
This example is a severe case of port gouging as a result of a broken ring.
You generally see it where you have just milled off a little bit of the edge of the ports, not where it comes down in a position such as this. This liner had to have some broken rings on the piston. This area right here is what condemns this liner.
And these conditions that Mac has described, if they're serious, scrap the liner, especially if cracks and heavy port framing or milling is visible. The next area to check is the top of the liner, across the gasket sealing surface. Be looking for any signs of damage or erosion. You might also keep a close lookout for any cracks that happen to be on the base of the upper pilot at the junction of the gasket surface. If you see any, well, this is a sure sign of overheating. Either one of these two conditions will be enough to cause rejection of this liner. The last visual check you'll need to make is down around the skirt of the liner. Check for milling. If this liner was run with even a slightly bent rod, the rod probably began milling a little metal around this area. If you see any, reject the liner. Like we said at the beginning of the program, a lot of close metal-to-metal contact occurs in the liner area. Because of this, there is going to be wear. Now, a piston has to fit in a liner with very close tolerances. And if the inside diameter of the liner is worn or honed out too far, the piston's fit will become sloppy. So EMD has come up with maximum specifications for piston fit. Before you do any honing or reconditioning to a liner, you should check the inside diameter of the liner to make sure that when you get through with the honing, the liner will still fall within EMD specifications. There's a tool for doing this called the liner bore gauge. The liner bore gauge will check for out of roundness and for liner inside diameter. At 3 points, 2, 6, and 12 inches from the top of the liner, you should take 2 readings 90 degrees apart to determine if the liner is out of round or out of spec. Your first reading should be made with the gauge pointing in the same direction as the crankshaft. Before honing, it shouldn't read more than 9 66/100 inches at 2, 6, and 12 inches. And if you see that there's more than 5 thousandths difference in the second reading 90 degrees away, the liner should be rejected. There's a possibility that the liner can be bored to 30 thousandths or 60 thousandths of an inch oversize, which is a shop repair and shouldn't be attempted on location. If you're using an oversized liner to begin with, you'll be able to tell by the inside diameter whether it has been bored and whether it can be bored again. Now, once again, before you start honing the liner, if it's close to exceeding EMD specifications and you have a scuffing or damage in the liner that you can feel, by the time you finish honing this liner, it will probably be out of spec, and all your time and effort will have been wasted. Be sure, before you put the effort into honing the liner, that it's going to be within specifications after you finish honing. After honing, maximum dimension allowable by EMD is 9 68/100ths at 6 inches deep into the liner, unless pistons and liners are selectively fitted. Then the maximum dimension at the 6-inch location would be 9 73/100ths of an inch, providing a piston of 9 51/100ths skirt diameter is used. This will ensure a maximum allowable piston to liner clearance at the 6-inch position of 22 thousandths of an inch. If not selectively fitted, the maximum liner diameter at the 6-inch position would be 9 68/100ths of an inch. Maximum dimension allowable at the top limit of piston ring travel is 9 83/100ths of an inch. Once you're through with the visual inspection of a liner, and it passes all the points that we brought out so far, the next thing you need to do is check the wear ridge. The wear ridge is a result of the rings wearing against the cylinder wall. When the piston is at top dead center, you'll notice that the rings don't reach the top of the cylinder. Since the rings aren't wearing on the upper 1 1/4 of the cylinder wall, this portion isn't subjected to quite as much wear as the rest of the cylinder wall is. This is what causes the wear ridge. Now, before the liner can be honed out, the wear ridge has to be removed. And removing it can be done on location if you have the proper equipment. You need a liner ridge reamer, which can be operated either by hand or with a heavy-duty drill motor if you use a speed reducer. Now, this is a critical operation, so be sure and read this portion over in your EMD maintenance manual, section 4, before you attempt it. However, if you don't have the proper tools, don't try to do this. Just go ahead and pack the liner up and ship it for reworking. And if you do have the proper tools, make sure you know how to operate everything correctly. And make sure that everything is in good condition. Then read the instructions in section 4 of your EMD maintenance manual. First, check the cutting blade of your reamer out and make sure it's in good condition. If it's not, you might have to resharpen it or replace it with a new one. Now, before you set the reamer inside of the cylinder, oil the cylinder walls. Be sure the felt pad in back of the cutter is full of oil. Naturally, you'll need to retract the cutting blade so it'll be out of the way when you set the reamer down inside the cylinder wall. The reamer should be set down inside the liner until the depth stop rests on top of the liner. Once you've got it seated down in there, go ahead and tighten the centering nut to hold the reamer in position. You ought to turn it 1 or 2 turns to make sure that it's centered up. Now you're about ready to start reaming. You'll need to pull the blade retarder cam back to allow the cutter to be released and move into position. Then turn the reamer a couple of turns manually to get it started. If you're using a motor, you can use an ordinary heavy-duty electric drill that operates at about 500 RPM without a load. But you will need to use a motor drive and speed reducer. Once the speed reducer is in place, you can start reaming with the motor. Keep plenty of oil on the surface being cut. Continue to turn the reamer until all of the wear ridge is removed. Once you've completed this, you can pull everything out and give the liner a good cleaning. Make sure that you get all of the oil and cuttings out of the liner. And be sure to check that the liner still meets EMD specs. Measure it where the rings reach their highest point in the liner. If it's more than 9 83/1000 inches, the liner can't be reused. Now the last step in reconditioning the liner is honing. For this, you'll need a honing kit, electric drill, stone cleaning brush, and a cylinder honing fixture. The reason that a cylinder is honed is to knock off the glaze and provide a surface that new piston rings can seat to, and to remove light scuffing. The object is to have a slightly rough finish inside the liner with a 45-degree crisscross pattern that covers the entire liner wall. This is done by moving the hone up and down in the cylinder at about 30 complete strokes per minute. This will give you the 45-degree crosshatch pattern that we're looking for. Now, before you go any further, make sure the cylinder you're about to hone is a cast iron cylinder. If it's a chrome liner, it'll have a mirror finish. Don't try to hone a chrome liner. Now, the hone has to be equipped with a set of W47-J43 stones and guides to protect the surface and finish it off to the proper roughness. Be real careful in installing these on the hone. If you damage them, you'll have to get a new set, and these things aren't cheap. Check and make sure that they're clean. If they're not, you might want to clean them with a wire brush. Before we get started, let's take a look at the way it's done in the shop. A cylinder is put into position in a rig similar to this. The rig makes 30 strokes per minute. The liner wall is continuously washed down with fuel oil. You're probably not going to have one of these rigs out on location. So the easiest way for you to set up to hone your liner is to set it in a tub that's capable of holding 10 gallons of fuel oil. The liner should be set in the tub, top side up. Fill the tub with fuel oil up to a point that the hone will be able to wash itself on the downstroke. As the hones turn and move up and down, the liner walls will be continuously flushed with fuel oil, and you want to make sure that the liner isn't going to be moving inside of your tub while you're doing the honing. Now set the hone into the cylinder so that the stones don't stick out of the top of the liner more than ½ an inch. On the center pinion assembly of the hone, you'll find a ratchet type affair for tightening the stones against the wall. They should be snug against the liner wall, but not torqued down. Now you're just about ready to start honing. Your motor should be capable of somewhere between 345 to 500 RPM. Start your up and down motion with 30 strokes per minute. Every now and then you might have to stop to tighten the stones up a little tighter against the wall. You should never let them run loose. This doesn't do any good as far as roughing the surface, and it could allow the stones to chatter inside the liner if they get too loose. This can permanently damage your liner. As the hone turns, if the pressure is right, you'll hear a steady grinding noise. Just hone long enough to break the glaze and be sure all of the surface area is honed.
Then you start hearing the drill motor spinning without any strain on it. Best thing to do is adjust your tool. And you can hear the drill motor straining just a little bit.
Do this at about 30 strokes per minute. This will give you that crisscross pattern in the liner at about a 45-degree angle. Depending on the amount of scuffing or out of round, it may take about 5 minutes to get the finish we're looking for evenly over the whole liner surface. If you hone for about 10 minutes and you still have unhoned areas, or if scuffing is still there, the liner will probably be beyond its acceptable limits. But if individual scratches are still there, after all other areas look good, don't worry about them. They don't hurt anything. You can stop honing and consider this liner ready for use. The next thing to do is clean the liner out completely. And you're going to have to be very careful when you do this, because what you have on the surface is abrasive iron dust, and if it's not cleaned off properly, those little particles will be left in the pores of the liner. This stuff is abrasive, and when the power assembly is installed in the engine, it'll grind the liner, the rings, and the piston, causing a lot of damage and wear in a short amount of time. It'll be worse than taking sandpaper to those surfaces. Now, to clean the liner, you want to use a detergent and hot water and a stiff fiber brush. Rinse the liner thoroughly with clean water and wipe it dry with a lintless cloth. Then swab the liner with a clean rag that has SAE 10-weight oil on it. This will help pick up the abrasive particles and help flush it out of the pores of the liner. Next, wipe the oil out with a dry, lintless cloth. If you do this 3 or 4 times, you ought to be able to pull your rag out of the liner without any evidence of particles at all. Finally, recheck the bore size to verify that it is still meeting specs. If you plan on storing your liner, make sure that you have plenty of oil left on the surface of the cylinder walls to keep it from rusting or corroding. To replace a broken liner stud, it'll probably be necessary to remove it with one of these gadgets or by drilling and using an easy out. Once the broken stud is out, a new stud may be applied after checking the threads in the liner with a tap. In addition to the standard size, there are various oversizes, as shown in the EMD parts catalog, in the event the standard stud is loose. The new stud should be driven so it extends 9.5 inches above the gasket surface. Use a minimum of 50 foot-pounds torque. Be careful. There are 2 different type studs on a liner. One is the liner locating or pilot stud. It has a shoulder just above the gasket surface of the liner. This stud can only be used in the position above and to the right side of the connecting point for the water inlet jumper. The second type stud can be used in any of the other stud holes. That's the inspection and reconditioning procedure for the liner. It's not too difficult, and it shouldn't take you over 2 hours to do the entire inspection and rework. Now it's ready for reassembly or storage. That's an expensive failure, and we can't afford this kind of a problem. The water pump might seem like a minor nuisance to you at times, but it can cause some pretty massive damage, like it did on the Sedco 472. That's why rebuilding it right is so important. The water pump has always been one of the weak points in the EMD. Most of the failure reports that we get in Dallas on water pumps are bearing-related problems. So EMD introduced a new sealed bearing to help improve the life and reliability of the pump. This bearing comes separately or as a part of their repair kit. Like I said, most of the problems you'll see with the water pump will be bearings, and they're usually pretty easy to determine. Mac McGee has some tips for you on this.
Basically, there's not any real good way of troubleshooting a water pump. The main thing is you'll find that the engine's not cooling, and of course, naturally, the first thing you suspect would be a water pump. The other is as you go around through your engine room, get accustomed to the noises that these engines create. As you walk past the front end of this engine and the noise sounds different to what it did yesterday, then go and check the water pump. You can take a screwdriver and put against this part of the housing for the bearing next to the gear train, or this part of the housing for the bearing out next to the impeller, with your ear against the other end of the screwdriver, and you can definitely hear the bearings running in that water pump. If you don't hear anything unusual there or don't recognize it, go to the other side of the engine and try that water pump. Most assuredly, both of the water pumps are not going out at the same time. If you hear a different noise on the other side than you do this side, whichever one's the roughest, that's the water pump that must be giving you the problem. One of the other things to look at is possible discoloration in this area right here. When you get that discoloration, that bearing has already failed. It's going out on you completely. The water pump is overheated in that area, and you need to shut the engine down immediately. If you do not change this water pump, you stand a chance on the gear of the water pump getting out of alignment with the other gears in the accessory housing, and the first thing you know, you've got a split accessory housing, which means all of the stuff on the front of the engine has got to be reinstalled and realigned.
The water pump's important, and it'll last longer if you do the overhaul right. Before you start your overhaul, make sure that you have a full EMD water pump repair kit. In addition to the bearings, it comes with most everything you'll need: the gaskets, seals, self-locking nuts and bolts. It's all in there. It's kit number 954768-3. Now don't skimp by trying to replace just the bearings. Compared to the price of a new water pump or the price of 8 power assemblies, it's cheap. In 1983, the full kit listed for $102, so don't skimp. When the PMS calls for an overhaul, put the full kit in. The removal and installation are pretty straightforward, but do remember to drain the cooling system before you go taking one off.
You remove this dresser sleeve back, take this line down, both ends of this line, remove the bolts around the face of the water pump where it goes on to the accessory drive housing, and slip the water pump out and bring it out of there.
What we're really interested in is the disassembly, the inspection, and the reassembly of the pump. Let's start with the tools. Some of them are special tools, but they're things you can make pretty easily on the rig. These two, for example, they help drive the bearings onto and off of the shaft. This green one's a 2-inch diameter pipe, 10 inches long. One end's got a plate welded over it. The red one's a 2-inch diameter pipe, 8 3/4 inches long. Notice that this wall has been beveled down on the inside diameter. We'll be using the gear puller, rubber mallet. The manual calls for a rawhide mallet, but this one works just as good, and various sockets and wrenches. And you'll need your repair kit. Before we start on disassembling the water pump, let's take a quick look at how it's made. The water pump shaft is held in the casing by 2 bearing assemblies. These bearing assemblies are spaced apart by a bearing spacer. The inner bearing is held in place by a retainer and snap ring to absorb the thrust in the shaft. On one end of the shaft is the drive gear. On the other end is the impeller. Both are locked to the shaft by Woodruff keys and held in place with self-locking nuts. There's an elaborate sealing system on the impeller end. It's made up of a carbon seal that seats against a smooth inner surface. It's held in place with a spring. Let's get started on overhauling the water pump. The mechanic on board this rig has strung a cable from the ceiling to suspend the water pump. This really helps make disassembly easier. He's also built a couple of handy mounts that help him in the overhaul. Let's take a quick look. This box is used to suspend the pump so that the bearing assembly can be dropped into place, allowing gravity to help keep it straight so that it doesn't bind, and so that the shaft can drop straight down without hitting anything. This pump support bracket was designed by one of the mechanics on the Sedco 471. It's pretty easy to make, and it makes torquing and untorquing the shaft nuts a lot easier without damaging the teeth. It's made out of a damaged idler gear. 1/6 of the gear has been cut out here and welded to a mount so that the pump drive gear is locked in place when the pump is bolted on. If you don't have a damaged idler gear, a half of a damaged drive gear will work just as good. The first thing you want to do is loosen the impeller nuts and suspend the pump gear end upwards so that it just clears the workbench. Then remove them. Once the nuts are off, the housing might let loose on its own. This one did. If it doesn't, use your rubber or rawhide mallet to wrap it and break it loose. Make sure that your water pump isn't more than a few inches from your workbench so that when the impeller housing drops off, it doesn't fall very far and get damaged. Once you've removed the housing, you can pull the pump off of your support. And now would probably be a good time to inspect that impeller. You want to be watching for problems like this. Things like this will cause the pump to be unbalanced and could cause other damage inside of the pump if it's reused. Be sure to look very carefully for any signs of damage at all that might cause the impeller to be unbalanced. Next, you'll need to mount the pump so that the drive gear and the impeller can be removed. We're going to use this little device because it doesn't damage the drive gear teeth. If you don't have the materials to make one of these, you could place the mounting flange of the pump in a vise using jaw protectors. Next, pull the drive gear nut and washer. Be careful not to damage the gear teeth if you're using a vise. Before you take it off, you also want to remove the impeller end nut and washer. Now, the drive end nut and the impeller end nut are both self-locking. They should only be used once. If you reuse one, there's a good chance that it'll loosen and come off inside the engine. There's the result of something like that happening. This drive gear loosened while it was operating inside of the engine. The vibration of the loose gear broke these teeth and these teeth on the idler gear. This type of repair, if this pump can be salvaged, will end up costing thousands of dollars and a lot of man-hours. So when you take these nuts off, be sure you throw them away. After you've got the two nuts taken off, you'll need to use your gear puller to pull the drive gear off. It's held in place with a Woodruff key. So you'll need to be sure and get the key out too. Next, you'll want to remove the bearing snap ring and bearing retainer ring. There's one thing you might notice here. Take a good close look at the edge of the housing. This one's been chipped and eaten away. We'll take a closer look at it a little later, but this housing may have to be replaced. Next, you'll want to put your gear puller or impeller puller on the impeller end of the shaft. Now, notice here that we're putting the legs across the outer housing and not on the impeller itself. If your impeller is any good, you'll damage it by putting the legs on the impeller. As you press the shaft out of the housing, the impeller will release and you'll be able to take it off of the shaft. You'll also free the shaft up as the bearings disengage from the housing. It's a good idea, once the shaft reaches this point, to go ahead and pull the impeller off and remove the impeller shaft key and the seals. The seals consist of a spring, a seal retainer, an outer seal, and a carbon seal. When you're rebuilding your water pump, these are some of the main items that are replaced. A little light tapping with a block of wood, and you'll be able to easily work the shaft and bearings out of the housing. Now, don't hit it hard. If it locks up on you, it's because it's coming out crooked. Try to straighten the shaft out as much as you can, and then continue to tap lightly with your block of wood. It shouldn't take a lot of force to get this out. The next step is to remove the stationary bushing. It's held in place by 6 bolts at the rear of the water pump. This is replaced too because the bottom surface is what the carbon seal seals against. If there are any scratches or scores at all, the seal won't have integrity. Once the 6 bolts have been removed from the stationary bushing, it may or may not come off easily. If it's stuck, maybe a few taps with a rubber mallet will loosen it. If not, there are 2 threaded back-off accesses. You can use the bushing bolts to back the stationary bushing off of the pump housing. The next step is to remove the bearings because we're going to replace them. The inner bearing has a snap ring groove, the rear one doesn't. Now, the shaft assembly consists of the shaft, the water slinger, the outer bearing, the bearing spacer, and the inner bearing. On the older bearings, both the inner and outer bearings are designed with an offset on one side. These offsets should always be positioned to the outside of the shaft. If you have any question as to which side we're talking about, the part number is stamped on the offset side. That part number should always point to the outside of the shaft. The new bearings are offset on both sides. Don't forget that the inner bearing has this snap ring too. Mount the shaft assembly in your vise with jaw protectors holding on to the bearing spacer. Attach your gear puller to the inner bearing and you can carefully pull the bearing off. Be careful not to drop the assembly when the inner bearing comes off. Then the bearing spacer will slide off. This tool that we were talking about earlier was made in the shop. It fits down over the bearing shaft assembly, and you'll notice that the edge has been tapered off so that it matches the taper on the water slinger. We're able to drive the bearing off easier with this thing without damaging the water slinger. This tool will only drive it off of its own bearing seat. Use the gear puller to pull it off of the other bearing seat. Once this is done, you'll need to give the shaft a good inspection. In fact, all the parts ought to undergo a very close inspection to determine whether or not they are reusable. Now, remember a little earlier, we were talking about this part of the housing. If you take a good close look, you'll see that there's a discoloration near the bearing area, and it looks like some parts of the neck have been overheated and chipped away. Whatever caused it, it's obvious that it'll have to be scrapped. Here, compare it to a new housing. See the difference? And also inspect the impeller for any damage at all. An unbalanced impeller will cause a lot of damage real fast. Be sure to inspect the impeller housing. Before reinstalling an impeller, check to make sure that all of its parameters are right. There has to be the proper clearance between the impeller neck and the impeller housing. Check the drive gear to make sure that the gear teeth aren't worn and to make sure there are no chips or cracks in the teeth. You'll want to check the wear on the gear shaft hole too. And be sure and check the impeller shaft. If it's out of round at all, you'll either need to replace it or have it turned. Now let's put the pump back together. The first step is to reassemble the bearing shaft assembly. The water slinger goes on first. Now take a good close look at the way that this is being installed here. Next comes the inner bearing. EMD's introduced a new bearing that uses a seal. This seal helps to keep the grease in the bearing area and will hopefully help extend its life for you. With these installed in the water pump, you should get well over 4,200 hours out of them. You can order the bearings with a new water pump repair kit. Here's the part number, 954-7683. This kit includes the gear end bearing and the impeller end bearing, as well as all of the seals and gaskets you'll need to rebuild the water pump. It also includes a new stationary bushing. We recommend that whenever you rebuild a water pump, replace all of these parts with the new kit. A little silicone grease on the bearing seating surfaces will make it easier to get the bearings installed. Here we're installing the old style bearings, but you'll probably be using the new style. The inner bearing is the one that does not have the snap ring groove. It can be installed either way if you're using the new style. If you're using the old style, there's an offset that should point to the outside of the shaft. A few easy taps. Be careful to make sure the bearing is going down straight on the shaft. Light taps should be all that's needed to get the bearing seated. If you have trouble driving it on, it may be because it's cocked. Be sure it's going on straight. You'll need to drive it down all the way, flush against the water slinger. Next, the bearing spacer sleeve goes on. It can go either way. Then, finally, the outer bearing, the one with the snap ring groove. The offset points outward. The snap ring goes to the outward side. Again, a few taps on the bearing will cause it to seat right into place. Once you've got this bearing on, check the bearing spacer to make sure that it's snug. And make sure that the bearings turn freely. Here, the spacer turns too easily, so we're going to have to snug it up a little bit. Now, that's about right. Be sure that both bearings turn freely. Next, set the water pump housing in a holder of some type. Before you install the shaft assembly, be sure to put silicone grease on the bearing seat surfaces. This will help when you install the assembly by helping to lubricate the surfaces as the bearings are driven through the housing. A little silicone grease on the inner bearing itself is a good idea too. Now you'll need to tap the shaft into place, slinger in first. It's going to be a tight fit, but you don't have to use a lot of force, just moderate taps. As you seat the outer bearing in the outer seat, make sure that the shaft is perfectly straight. Then go ahead and drive the shaft and bearing assembly all the way down until the snap ring meets the groove that holds it in place. Once the bearings in the shaft have seated themselves, install the bearing retainer ring and the snap ring. Make sure the snap ring seats all the way. Once you've got the snap ring in place, make sure that the shaft still turns freely. The next thing to be installed is the stationary bushing. Make sure it's perfectly clean. This gasket goes between the bushing and the housing. You should use those 6 special self-locking bolts on this bushing. As you tighten the bolts down, make sure you tighten them in the right pattern. Tighten them to 50 inch-pounds first. Then torque them down to 100 inch-pounds, or 11.3 Newton-meters. Once you've got them torqued down, make sure that the sealed surface area is completely clean. Before you install the rest of the seal, you need to check the runout on the carbon seal to make sure that it's seating right. You do this with a micrometer. Check it out to specifications in your EMD manual. First, we'll install the carbon seal like this. Again, make sure everything is perfectly clean. There are 2 feet on the seal retainer that fit into notches in the carbon seal. The flat side of the outer seal should contact the carbon seal. The concave side should fit up against the inside of the seal retainer ring. Make sure those little feet seat down inside the slots in the carbon seal. Before you install the seal spring, you'll want to put the impeller key in place and check the depth of the key against the shaft key seat to make sure that there's clearance. The narrow end of the spring goes in first, and this foot on the spring fits into the tab of the seal retainer. Now we can install the impeller on the shaft. Notice when you get this installed that the large end spring foot fits into a notch in the impeller. You'll need to make sure that this seats while you're installing the impeller. The best way to do this is just make sure that the foot is positioned 180 degrees away from the impeller shaft key. Otherwise, the impeller won't seat. Now we can install the drive gear key and the drive gear. When you're installing this gear, make sure you put it on the right way. If you look at both sides of the gear, you'll notice that one side has a deeper inset than the other side. The deeper inset should go toward the housing. Next, secure the assembly. Both of these nuts have got self-locking devices on them. You should only use them once, then they should be thrown away. New ones are not included with the kit, so you'll have to order them separately. There have been a lot of pumps in the field that have been damaged because one of these nuts came loose. We've already put the drive gear washer on. This nut gets torqued down to 265 foot-pounds. On the other end, we install the impeller end nut and washer. This nut gets torqued down to 80 foot-pounds. All that remains now is to install the impeller housing into the main housing. The housing gasket goes on first. Notice on the impeller housing, molded in the housing itself, there's the letter R, and if you turn the housing around about 120 degrees, you'll find the letter L. If this is going to be a right side pump, line the diamond stamped into the pump housing up with the R. If it's going to be a left side pump, line the diamond up with the L. This particular pump will be a left side. Make sure that this spring and roll pin are in place over the tattletale hole at the drive gear end of the pump housing. If the balls in the ball bearing break apart, this spring will keep them from falling into the gear train area of the engine. All that's left is to torque these nuts down to 65 foot-pounds or 88 Newton-meters. Wrap a protective cloth around the teeth of the drive gear and cover the ports of the pump so that nothing falls down inside of it while it's in storage. If you're going to go ahead and put this back in the engine, you don't need to cover the ports. And finally, you'll want to paint the case to keep it from rusting. If you're installing this pump,
one of the first things you want to make sure of is that your gasket surfaces here, here, and here are clean. You install the water pump, tighten these bolts up into the housing. Next thing is you put on this discharge elbow. You need to start all of these bolts, and you start these 4 bolts, and then you tighten them up equally until you've got them both tight and you don't break this flange on this line. The next thing, you install this dresser sleeve. The only thing that you've got to be cautious of in this dresser sleeve is to make sure that the rubber seals under those clamps are pliable. If those rubber seals are not soft, you need to change them and get some seals in there that when you clamp up, will be sealed off from the water in these areas. Okay, when you're overhauling this water pump, either taking it off, overhauling it, or reinstalling it, be sure that you have your instruction manual out for anything that you're not completely familiar with. Do all of your work on this water pump according to the prescribed manner.
that's about it for the water pump. Be sure you do a good job because a faulty one can cause a lot of damage. There's a lot of motion around the head. The valves are moving, the water's flowing through it for cooling, and there's all that action and pressure at the firing face. Just like the rest of your power assembly, the head is a critical part of your EMD. This time around, let's take a look at the head and what you're going to be doing to get it repaired and back onto the power assembly in top-notch shape. After you get it off of the power assembly, there are several steps before we begin the repair work. Some of the tools you'll be using are a valve spring compression tool, valve seat reconditioning tool set, valve checking tram and feeler gauge, valve seat seal tester, and a bottle brush. First, we'll have to disassemble the head, which takes just a few minutes, and the valves are the first items to come off. It doesn't matter whether you use a single or double spring compressor. We're using a multiple compressor here. It simply screws in to two threaded holes designed for the tool. Once it's screwed in, bring the handles down to a horizontal position. This will allow you to get to the valve locks so that the springs can be removed. Once the locks are removed, release the spring compressor and remove the tool. The springs and the retainers will come right off and the valves will slide out. That's really about all there is to disassembly. Now let's take a good look at the head. First, check the firing face. Look for cracks which are caused from overheating or damage from pieces of broken ring or broken valves. Also, look for excessive wear at the valve seat. If you have broken or bad springs, you might have some wear problems where the springs seat into the head. Check here, too. Now, you might have noticed when you pulled the head off that your head-to-liner grommets were cooked out. This means that the head overheated and was probably damaged to the point that you can kiss it goodbye. If these grommets appeared to be okay, and you didn't see any physical damage, then you can go on to the next step, which is a thorough cleanup. You need to use a suitable solvent like Varsol or fuel oil to loosen that baked-on carbon. It's okay to use a scraper on the outside diameter and the portion of the firing surface that's smooth. But on the portion that's grooved like a phonograph record, you should use a wire brush in a circular motion to help get down into the grooves and clean them out. The stud holes, injector well, and valve guides need a good cleaning too. Use a bottle brush with a stiff fiber bristle. Everything has to be really clean. That's important in the next inspection step and in the life of the head. And that means less work for you in the long run. Don't forget to clean the rest of the parts too. The springs, spring seats, and spring locks or keepers should be cleaned with the same kind of solvent. Now keep in mind that the problems are easier to detect on a clean head, so any extra effort in cleaning at this point will probably pay off. Once you have all the cleaning done, we can give the head a more critical inspection. First, we'll check all the parts visually. Then we'll give the head a water test and dye penetrant test, and we'll check the head dimensionally. The eyeball test is first. Look for cracks. Cracks are most likely to occur on the face between the exhaust valve ports or between the exhaust valve ports and the injector well. Inspect the whole head because it's possible you could get a crack somewhere else too. Take a good close look at the valve seats. They should be smooth. Is there any channeling or what you might call guttering or burning? Any signs of these problems could be cause for rejection of the head. Scratches or nicks in these areas will mean that the head will need fireface refinishing, something you'll have to send into the shop to have done. Small scratches or nicks in the phonograph finish area, which are not in the sealing areas, won't require refinishing. Check all the sealing areas, like the head gasket area, and where the grommets are placed in the water cooling holes. Once you're sure all the gasket areas are okay, go ahead and check out the exhaust valves for any obvious cracks or channeling or fretting. Look for wear on the stem and the lock groove, or anywhere along the entire stem surface. If you find any of these problems, you can just pitch the valve in the trash. Any valves that look okay should go to a shop for proper reconditioning. This is something you can't do justice to on the rig. Valve reconditioning is just too critical. Leave it up to somebody else. In other words, we're going to be using all new or newly reconditioned valves in our rebuilt head. It's the safe thing to do. Okay, so much for the eyeball test. Let's get down to the real testing procedures. First is the water pressure test. There are two different ways you can do this. You might have one of these pressure test jigs, or you can make one up. It's nothing more than a plate that can seal the water passages off. It bolts onto the firing face of the head. Now apply about 90 to 100 pounds of air. Stick it down in water with a temperature of about 160 degrees. You will need to keep the head submerged for about 2 minutes and maintain a temperature of 160 degrees. The hot water helps to open up any of the small cracks so that leaks can be easily detected. If you can't do this on location, there's another way to test for small cracks. It's not quite as good, but it'll work better than just eyeballing. Use the same kind of plate bolted on the firing face. Notice that it has the center cut out to reveal any leaks that may show up around the valve ports. Now, bolt the water line onto the discharge surface, same as you would have if it were air pressure. Send in about 40 or 50 pounds of water. Of course, your head should be absolutely dry to help you determine where any leaks might exist. Leaks around the core plugs can usually be fixed by replacing the core plug with a new one. A leak anywhere else on the head is a good indication that this head is scrap. At this point, just a reminder, always read your manual before you do repair of any kind. Anytime you got a question or you're not sure about something, check your manual. It's got the specifications on all the parts and can clue you in if you're not sure whether or not one of the parts is bad. Okay, the next test is a dye penetrant test. You'll be doing this on other parts too, like the piston. This test is a substitute for magnaflux, so if you can perform a magnaflux, do it. It's better. If not, here's how the dye penetrant test is done. It's a three-part system to expose cracks. The first part is a red dye that you spray on and let set for a couple of minutes to soak into any cracks that might be present. Be sure those suspect areas, like the valve ports and facing at the water discharge, are well covered with dye. Now, use the spray cleaner and a clean rag to get the red dye off. When you've removed all of the dye you can, take the light gray or white spray and apply it thoroughly, as you did with the red spray. Within a few seconds, the red dye will show up anywhere there's a crack, just like this one. Most all cracks that occur will be between the valve ports and the injector well. Double check these areas, as well as the machine surface of the water discharge elbow. If everything checks out all right, go ahead and clean it up. If you do have a crack, no amount of liquid steel or anything else is going to make that head work, so you might as well scrap it. Okay, the last check before we begin reworking the head is the dimensional check. Measure the inside diameter on the valve guides at two places, 1/2 inch from the top and 1/2 inch from the bottom. If either reading is more than 633 thousandths of an inch, you'll have to replace them. Look for any evidence of galling in the guide or bore areas. One other dimensional inspection you'll need to make is an inspection of the valve seats. You have to find out if the valves are too deep into the head. The maximum is 93 thousandths of an inch. To do this, get the head positioned with the firing face up. Put a new valve in each of the valve ports. Then measure the vertical distance from the fire face of the head to the rim of the exhaust valve. If it's more than 93 thousandths of an inch deep, you'll just have to junk it. Now for the fun part, reworking the head to make it ready for the hundreds of hours of good service it's going to give you. The first step will be to replace any valve guides that may be worn out. Then we'll take a look at the valve seat grinding, which is the most critical step. And finally, we'll go over reseating the valves and reassembling the head. Now, if your valve guides do need to be replaced, here's how you do it. Put the head upside down on the press. Block it so that the firing face is parallel to the press platform, and the guide to be removed is directly under the press. Get a guide removal tool and insert it in the guide bore. Move the press down, making sure that the pressure is smooth and even. The old one should press right out. It's just about the same to put a new one in. Turn the head over so that it's right side up. Wood blocks, plywood, or masonite are good to use because they won't cause scratches on the firing face. Again, put the opening right below the press. Put a little lubrication on your new guide. Use Lubriplate or something like that. Insert it into the head and just barely get it started. Put the installation tool on and press it in very slowly, making sure that it doesn't get cocked. Take it down until the shoulder bottoms. Make sure it goes in straight. The guide should have a press fit of 5/10,000ths to 2/1000ths of an inch. That means the guide should be that much larger than the guide bore. If you can't get this tolerance out of a standard guide, there are two oversizes you can use. One is 15/10,000ths of an inch. The other is 15/1000ths of an inch. You can find these in the replacement parts catalog. If the oversize is what you need, you'll have to have the bore reamed so that an oversize will fit in correctly. A 15/1000ths of an inch oversize guide needs a 5/10,000ths to a 2/1000ths of an inch press fit. Once that's done, the head is ready for the valve seat grinding process. Now there are several special tools that you're going to need for this, like the tapered pilots, a spring and grinding wheels, a dressing tool for each grinding wheel, and a dial indicator. The first stage of the process is to dress each grinding wheel. The angle is extremely critical. That's why you need a separate dressing tool for each grinding wheel. If you only use one dressing tool to dress all three angles, the setting is constantly changed for the different angled wheels. The same wheel will never get the same angle dressing 2 times in a row. That means shorter grinding wheel life and, what's worse, a screwed up valve seat and maybe even a scrapped head. The dressing tools should be set and left alone on that setting. Get your first grinding wheel. Lightly oil the dressing tool pilot and mount the wheel on it. Adjust the spiral sleeve until the wheel just touches the cutting diamond. There's an adjusting screw here to make the final adjustment. Check it by hand, turning it before you begin. Then apply the motor and spin the wheel. Make light strokes with the diamond. When you've got a nice smooth cut on your wheel, go on to the next one and give it a good finish. Now that the dressing wheels are properly dressed, put the head upside down on the workbench. Block it with wood like before to make it level. Now put an abrasive cloth between the valve and the valve seat and turn it by hand to clean the seat off. Stick the tapered pilot into the valve guide. It should be snug inside the guide, and the pilot shoulder should not touch the guide. It should get tight before it goes down that far. When that's done, lightly oil the tapered pilot. Put the lifter spring on, and then the 30-degree grinding wheel. Now the drive motor. Hold it as straight as you can and begin grinding. Don't use any more pressure than just what the weight of the motor provides. Keep grinding until the seat width reaches 93 thousandths of an inch. The maximum width should be 125 thousandths of an inch, but you want it as close as possible to 93 thousandths of an inch because that means you could grind it again when the time comes and still be within specs. Raise the drive motor before shutting it off. This will cause the spring to raise the grinding wheel off of the seat and prevent scratching the seat when the wheel stops turning. After the 30-degree wheel, the 65-degree wheel should be applied. Here, we're grinding this area to clean up adjacent to the 30-degree area. All right, let's get the 20-degree wheel. It brings the outer area down farther and further accentuates the area that will be the valve seat. You can see how this process refaces the valve seat and gives you a good clean seat for the valve to seal against. Next, you'll need to check what you've just ground to be sure that the valve seat has the proper dimension of 93 thousandths to 125 thousandths of an inch. You might want to check the specifications in Section 2 of the engine manual. You'll need to use the dial indicator to check valve seat runout. That's the position of the valve seat in relation to the center of the valve guide stem. The indicator should be placed over the pilot and adjusted so that the ball of the gauge is slightly depressed against the valve, and so that the ball is at the center of the 30-degree seat. Rotate the rider and watch the indicator reading. Ideally, it shouldn't move at all, but you can accept a runout of no more than 4 thousandths of an inch. If all checks out well on all 4 exhaust valve seats, you can install the new exhaust valves. Now remember, don't use your old valves. Use only new or reconditioned valves. Drop one in each of the exhaust ports. We'll need to check the vertical distance from the fire face. Take a straight edge and lay it across the fire face over the flat of the valve. Check with a feeler gauge to see what the distance is between the flat of the valve and the straight edge. It shouldn't be any greater than 93 thousandths of an inch. If it is, and it's a reconditioned valve, replace it with a new valve to try to get the required dimension. If it's still greater than 93 thousandths of an inch, the valve seat has been ground too deeply into the head, and the head will have to be rejected. Before installing the new valves, the head should be cleaned to get rid of all grinding deposits. If all 4 valves pass this test, carefully turn the head right side up. Be careful not to slide it around. You might scratch the fire face. Now install the valve springs and valve spring retainers. And put the spring compressor in place. Now, compress the springs and install the valve keepers. Make sure that they're in good condition before you put them in. Then you can pull the valve spring compressor off. All right, with the valves now in place, you'll need to check the stem height. This tool can do it, and it's called a valve checking tram. Again, Section 2 of the manual will explain this if you have any questions. Put the tram down onto the head surface. The tram feet and head surface should be smooth and clean. Apply it so that the adjusting screw can check the 2 valves that'll be under the same valve bridge. You might have to loosen the screw to make it fit. Adjust the screw to fit the taller of the 2 valves. Now, slide it over the other valve and check the clearance with a feeler gauge. The clearance must not be more than 1/16 of an inch. If it is, replace the high or longer valve. Don't grind the valve tip, because these are hardened surfaces and grinding could make them crack. Check the other pair of valves too. Remember, 1/16 of an inch is the maximum clearance. With that done, flip the head over and rest it gently on the rocker arm studs with the firing face toward you. You should have a valve seat seal tester. If it's old, you can test it on a piece of glass. It should stick for at least 2 minutes. To test the valves, clean off the face real well and put a light film of oil on the tester cup. Stick it on over one of the valve seats. The handle ought to be in the 6 o'clock position. That way, if the suction is lost, the tester will fall off and you'll know if the seat is bad. It should stay for at least 2 minutes without losing suction. Just pull the release trigger to get it off. If the suction tester falls off in less than 2 minutes, the seat will have to be reground so you can get a better seal. That's it. Now you ought to be sure and return your old valves to a shop for reconditioning. Remember that we only install new or reconditioned valves into our heads. Your head should be ready to go unless you have a broken stud or a stud with damaged threads. One of these stud removers should remove it. If not, a 1-inch flat washer and nut can be welded on top of the stud. That way you can just back it out with a wrench. Be sure to weld the inside of the nut to the stud. Always clean out the threads with a tap before you put a new one in. Standard and oversized studs can be found in the parts catalog. If the stud is more than 4/1000ths of an inch oversized, you'll need to use an oversized tap. The stud should extend 6 1/4 inches above the head. A 1/16 of an inch either direction would be okay. In other words, 6 3/16 inches to 6 5/16 inches from head surface to the top of the stud. Torque it down to between 150 and 400 foot-pounds. Great! You now have a like new head, ready to help complete a top-notch power assembly.